single loop circuit. So you only have one loop in these problems. We're going to be looking at it, which means all the elements will be connected in series. When we talk about connected in series, this is like if you pretend these are hoses at your house. You want to water the garden, but the hose doesn't reach. You bring in another one and you put it through. That's connected in series. You bring a third one. That's connected in series. Why? Because the water going through this hose is going to be the same water going through this hose, the same one going through this one. So that's what series connection looks like. So the current will be the same. The voltage will not be the same unless the resistors are equal. That means they have the same current. Think of the current like water. Water going through the hoses. You attach 2 or 3 hoses. There's no just one to the next one to the next one. I don't know if you can see it on camera. To the next one. So now, here we go. The water going through this is going to be the same water going through this, the same water going through that one. The current through this is going to be the same as this, the same as that. So now we're going to take the problem and see what will happen here. And maybe we'll calculate power, whatever they want us to calculate. Now, sometimes we bend it instead of making it look nice and neat. So I might have a problem that looks like this. I'll make some values, 10 ohms. 5 volts. 30 ohms. 50 ohms. I'm making just the numbers up here. And let me call this 3 V1, and V1 is this voltage. So that's a dependent voltage source. It depends on the value of this. Our book has a habit of taking a problem and bending the wire just to make it look different. Now technically I can take this problem now and redraw that. And me, I like to put the source on the left side, just me. So I'll put the source minus to plus, and I put the 5 volts here. Going up, what's attached to that 5 volts? The 30 ohm, right? And this is V1. They bend the wire. Do I have to bend the wire? No, I don't have to bend my wire. I can continue. That's 50 ohms. What else comes after that? Notice I'm traveling this way. I get the plus to minus. 3V1. And I might bend this because I need to come back home here. And I put the 10 ohm resistor right there. That's the same exact circuit. It looks different, but exactly the same. Now, what do we know about the current going through them then? How are they connected? Notice again, just like taking these markers, you take the top of one, you attach it to the bottom of the other one. They are connected in series. You take this one, attach it to that one. Just put an elbow there. You take this, attach it to that one. That's in series too. So is this, so is this. So the current going through them is going to be the same current. So I'm going to pretend I have no idea which way the current is going to flow. I'm going to pretend that the current is going to flow this way. We'll call it I. Now, if the current flows this way, it's going to mark this resistor plus to minus. And it's going to mark this resistor plus to minus. If I'm right. Now, when I do my math, if my current comes out negative, that means, it's going to go backward. I don't have to redo the math, but it just says the current is going to travel backward. And the question here to calculate the power absorbed or supplied by each one of these elements. I'm going to do both. I'm going to calculate the supplied and the absorbed and see if the sum of the supplied equals the sum of the absorbed. It should be. Okay. Last class we talked about Kirchhoff current law, Kirchhoff voltage law. Kirchhoff voltage law said if you have a loop there, sum of the voltage, the algebraic sum of all the voltages in a closed loop is always 0. That's what KVL. There's one loop. So if I add all the voltages going through that loop, the sum is 0. So let me use KVL here. So KVL, sum of the voltage in a closed loop. Let's begin with this. We're going to enter this from which end? The minus. That's a minus 5. Plus. What's this voltage here? Is that V1? Plus, I'm traveling, and what's the voltage across that 50 ohm resistor? Do we know what that voltage is? Right here. We don't know it. So if you called V2 and you call that V3, you're going to have one equation by how many unknowns? 3 unknowns. We got a problem. But let me just write down, let's say the voltage across the 50 ohm resistor. I'll leave it like this. I got to come up with a solution to that. Plus, this is plus to minus, that's plus 3V1, because that's a dependent source, plus the voltage here, which is the voltage across the 10 ohm resistor, should equal to 0. We got a problem. We got one equation by 3 unknowns. None of us can solve it. None of us. Okay, well, let's go back to Ohm's law. Ohm's law says, wait a minute, let's look at V1. The voltage here is what? V equals I times R. Do we know what R and I is? I is I, and what's R? 30. That's 30I. Let's look at the voltage across the 50 ohm resistor. Ohm's law again. The voltage there is what? I times R. I is unknown, and we want what R is what? 50? So what do we have? 50I. And the last one is, do we know what the voltage across that 10 ohm resistor? I times R. R is 10. That's 10I. So if I do that substitution for V1, V2, and V3, what are you going to have? V1 is what? 30I. Plus the V50, which is what? 50I. Plus 3 times V1. 3 times, what's V1 equal to? 30I. Plus the V10, which is what? 10I. And what happens when I take the negative 5 from this side to that side? Ends up being 5. How many unknowns now do I have in my equation? 1 unknown. I should be able to solve it. 30I plus 50I plus 90I plus 10I equals 5. That's 100, 180. I equals what? 5 divided by 180. 0.028 roughly. Or 28 milliamps, if you want to use engineering notation, 28 milliamps, because they don't like 0.028. But so we have 28 milliamps. Once we know the current, we know everything else. Let me go back, redraw the circuit again one more time. Here's what I'm going to have. Five. This is the 30 ohm resistor. It's going to be marked plus to minus. Do we know what the voltage, by the way, here? That's V1, 30 times I, right? We know what I is. We know what 30 is. What's 30 times 28 milli? 30 times 0.28. 0.028. Is that 0.84? That's what the voltage, 0.84 volts. Then I have another resistor. That's 50. We know what the voltage there. 50 times 0.028. 1.4. We have a dependent source now. We know what the value of that is. 3 times V1. V1 is 0.84. What's 3 times 0.84? 2.52. And finally this one, which is what? 0.28. By the way, if I add these numbers, they should add up to what, the voltages? 5. So unless rounding error there. But let's see, 0.84 plus 1.4 plus 2.52 plus 0.28 equals 5.04. Rounding error. Now let's calculate the power absorbed or supplied. Remember, the current is traveling which way? The current, the arrow, the tip of the current, it's going this way through this. It's going this way. It's going this way. It's going this way. It's going this way, coming back. That's how the current is going. So apply the rules of the power. If the tip of the current enters the minus sign, the power is negative and it's supplied. So here's the supplied power, and here's the absorbed power. We have the tip of the current entering the minus, that's supplied. Power is going to be supplied, that means negative. The voltage, which is 5, the current 0.028, was it? V times I, that's a negative. 5 times 0.028. 0.14. What? Look at the absorbed power. Tip of it entering which one? The plus. See that? That's entering the plus. That's a power. That's positive. It's taken. The voltage 0.84. The current 0.028. That's the 30 ohm resistor. We'll label them so you'll know which one's which. .024. Oh. Let's look at the 50 ohm. It's also taken power because that's plus to minus, the current entering the plus. 1.4, that's the voltage, the current 0.028. 0.039. The power by the dependent source, so you'll see that's a dependent source, is going to be positive. Again, you have a plus current entering the plus terminal. The voltage 2.52, the current 0.028. The answer 0.071. And the last one, the power absorbed by the 10 ohm resistor. It's going to be positive. Voltage 0.28, current 0.028. And I got 0.008 roughly. And now let's add them. There's no more. If I add all these, should equal close to that number. So here we go. Plus 0.071, plus 0.039, plus 0.024, and the answer is 0.142. Look at that number. The power taken absorbed equals the power supplied. Conservation of energy.
But technically, just like, you know, thinking about it like physics-wise, if you will, the wire is going to conduct heat, so it's probably going to lose a little bit of power through that, correct?
Well, right now these are ideal wires.
Mm-hmm.
Yep.
Yeah.
Yep. So when we do these, the wires have zero resistance. In real life, we'll get to that later in the course. Wires don't have zero resistance, and you're going to lose some power or energy there. So the power factor is no longer a 1. You don't get what the power company sends you home. Mm-hmm. You get a portion of that. And it depends how old and what kind of wiring you're using. Let me try another one. So different example. Let's say we have a 9 volt here. 3 volts here. 100 ohm here. Minus to plus 5 volts. Plus to minus 1 volt. And we have 200 ohms here. I don't know. And again, I want to find the power supplied, absorbed by each one of these elements. And I have no clue which way the current is going to flow. I mean, I can look at it, try to figure out, but I don't want to at this point. So I can make an assumption. I say, you know what? I'm going to make an assumption the current is going to travel this way. If it travels this way, it's going to mark this plus to minus. If it travels this way, it's going to mark this plus to minus. The sources, you can't change them. It's a battery. The plus on it is labeled. You can't change it. You know what? I feel like I'm going to make this the minus, that's the plus. It doesn't work that way.
It always has to. Is it supplying or absorbing?
Which one?
The resistors.
Well, based on the picture I drew there, it's going to absorb some power.
Okay.
Because you have the current entering the plus end of it.
Mm-hmm.
And it should be absorbing power.
Yeah.
But the current might be going that way. Still going to absorb, but will be plus to minus in that direction. So again, I'll use KVL, one single loop. The algebraic sum of all the voltages in a closed loop in one loop is always a 0. Let me begin with this one. I'm entering the minus, also that's not minus 9. minus 9. I'm entering the plus here. That's plus. And I can jump into Ohm's law. Ohm's law says the voltage here is what? R times I. Do we know what R is? 100. Do we know what I is? We're looking for it. Minus to plus, that's what? Minus 5. Plus to minus. Plus 1. Plus to minus. What's that resistor? 200. That's 200I. Minus to plus. Minus 3 equals to 0. Now, how many unknowns do we see? 1. So 300I equals, if I do the math, 14, is that 16? Darn it. I should have made this, you know what? Let's make this 220, this resistor. Makes the math easier. Let's make this a 220 here. It makes the numbers nicer, whole numbers. 220. So if I make this 220, what do we have here? 320?
50.
So I becomes what? 16 over 320. Is that 0.05?
Yeah.
20. Makes a whole number. Where if I left it, the other number has more digits to it. That's the only reason I changed that. Just to make the number a little bit nicer. So I changed that resistor from 200 to 220 just to make that number nicer. Now let me go through that and calculate the power by each one. Supplied versus absorbed. Let's see. We know I is 0.05. Supplied power. And this side absorbed. Let's see, supplied. Let's start with the 9-volt source. Is that supplying or absorbing? That's supplying. Why? You get the tip of the current entering the minus. That's negative. The voltage 9. I is what? 0.05. Negative 0.45. The resistor, the 100, that looks like it's taking power. Positive. I squared times R. What's I? 0.05 squared times 100. I can use I squared times R to calculate that, right? So 0.05 squared times 100, 0.25. Now I get to the negative 5-volt source here, or 5-volt source. I'm entering the minus. That's what? Supplied.
Why is it 0.05 squared again?
I squared R. Power is...
Oh, yeah, I squared R.
Yep. Negative 5 times 0.05. Is that 0.25? We get to the 1 volt. Notice I'm entering the 1 volt from which end? The plus. That means going to observe that. Is going to be the voltage, which is 1, times the current, that's 0.05, positive 0.05. The 220 is going to absorb power. Positive I squared, 0.05 squared, times R, which is 220.
You might want to move it over just
0.05 squared times 220, 0.55. And the last one is what? The source, the 3 volts, I'm entering from the minus, that's supplied. Three times 0.05 is negative 15, is it? I think 15. Let's add them both and see what the sum is, if they are equal. And let's add this, 0.55 plus 0.05 plus 0.25. Here, 0.85. That's how much we observe, 0.85. Let's look at these guys. 0.45 plus 0.25 plus 0.15. That's a minus 0.85. The minus being supplied, and the plus tells you was absorbed here. So again, what do we have? Conservation of energy.